MCQ with one or more than one correct answers. So we have the titration curve given between pH values as volume of base is added. In the first titration, we find that the sudden jump in the pH near the equivalence point of around 35 ml is 4 to 9.7. This is called titration range. So for 1, the titration range is 4 to 9.7. So any indicator whose pH range falls under this can be used as a suitable indicator. And from 2, what is that we can understand is that near the equivalence point of around same volume, it is titration range is coming out to be 7.46 to 10. So it is in basic medium. Whereas in 3, about 60 ml, it is 6.5 to 4, the titration range. So falling in acidic medium at the end point. This is what we understand the titration ranges for the different acid-base titrations. The question number 1 given on this is, graph 1 represents titration of strong acid, strong base, so that both HPH, here HPH stands for phenolphthalein as an indicator, and MEOH stands for methyl orange. So when graph 1 represents the titration of strong acid and strong base, both phenolphthalein and methyl orange can be used as an indicator. So if it is really strong acid, strong base titration, naturally we can use both of them, so that we can understand from the graph. So the graph is, the titration range is 4 to 9.7, and this 4 to 9.7 titration range will be generally for strong acid, strong base titration. So therefore graph 1 representing strong acid against strong base is right, and the titration range in the first graph being too big, from 4 to 9.7. So any indicator whose pH range falls in this can be used. So both acidic indicator as well as basic indicator can be used. So the statement A is right. Graph 2 represents titration of benzoic acid with sodium hydroxide, where this benzoic acid in general we can take it as, say, weak acid, titrated against sodium hydroxide, NaOH, so strong base. So when this titration between weak acid and strong base is carried out, the solution at the end point will be basic. So any indicator in basic range such as phenolphthalein can be used. So what is the statement given? Graph 2 represents titration of benzoic acid with sodium hydroxide. So this is the graph 2. In this, the range is 7.46 to 10, as we could see here in basic medium. And the pH starts initially before the base being added is around 3, indicating that it is a weak acid. So thus graph 2 represents the titration of benzoic acid with sodium hydroxide is correct. Methyl orange cannot be used as an indicator when phenolphthalein can be used in basic medium, and methyl orange is used only in acidic range, but the titration range is in basic medium. So phenolphthalein can be used, methyl orange cannot be used, is right. So therefore B is right. Graph 3 represents a titration of weak acid like boric acid against a strong base KOH. So this is not correct. You can see the graph is starting with pH of 12, and as the base is added, that is decreasing, and we are going for option C is weak acid like boric acid. So the pH cannot be 12 to begin with, therefore this is wrong. Graph 4 represents, this is graph 2. Graph 2 represents titration of acetic acid with potassium hydroxide. HPH cannot be used as an indicator. So let us compare B option and D option. B option says graph 2 represents titration of benzoic acid and sodium hydroxide. Here it is acetic acid with potassium hydroxide. Same, acetic acid is a weak acid and potassium hydroxide is a strong base. That titration, this titration is very similar. Here methyl orange cannot be used means phenolphthalein can be used because it is right. Here phenolphthalein cannot be used as an indicator is given. In fact, phenolphthalein can be used. Therefore, this option is wrong. Thus, A, B are the answers for the question.